Welcome to the Buoyancy and Archimedes Principle Lab. In Exercise 1, we'll be directly measuring the mass and volume of our wood and metal spheres for density calculation.
Place each sphere on the digital balance and record their respective masses.
You will also need to accurately measure the diameter of each sphere using a vernier caliper or digital caliper.
In Exercise 2, we'll be calculating the density of the sphere using its weight in air and its apparent weight when submerged in water.
Hang the metal sphere from the spring scale using the supplied string. Measure the weight in air, then lower the sphere until it's submerged, and measure its apparent weight in water.
In Exercise 3, we'll be finding the density of the wood sphere, which is less than that of water.
Hang the wood sphere from the spring scale and hang the metal sphere from the wooden sphere. Submerge only the metal sphere and record the weight. Then submerge both spheres and record the new weight.
In Exercise 4, which is optional, you would use the measurements from Exercise 2 and repeat them for a different liquid.
In Exercise 5, we'll be investigating the effect that submerging an object has on the weight of the liquid it is submerged in.
Place the beaker of water on the triple beam balance and measure its mass. Note that the digital balances we have in the lab can't handle as much weight as the triple beam balance.
Hang the metal sphere from the spring scale and submerge it in the beaker. Readjust the triple beam balance to measure the new weight and note whether it has increased or decreased.
In Exercise 6, we'll be determining whether or not a piece of the Greek king's crown that we just happen to have laying around the lab is made of real gold or not.
You will need to devise your own method for this part of the experiment using the skills you've learned from the previous exercises.
For Exercise 7, you will be directly measuring the weight of liquid displaced by an object.
You've been provided with an overflow can. Using it and any other equipment that is accessible, design a method to prove Archimedes' principle.
Thanks for watching the Buoyancy and Archimedes Principle video. Please note that once you've proved Archimedes' principle, don't run around the lab naked yelling Eureka. We've had problems with this in the past.